Okay, example 15. Okay, in this question you are given the equation of the line L in vector equation form, and then they tell you that you have a point Q, and this point Q is on the line L. Condition is that the length of OQ is 5 units. So your job is to find the possible vectors, the position vectors of Q. Okay, so a few understanding from the concept of lines. This is a vector equation of a straight line where t can take infinite values. So if I want a point that's on a line L that's given to you, the t must take one specific value. So I'm going to let the point Q is on the line L. Okay, I'm going to let a special value of t to represent the point OQ. So since Q is on line L, OQ must have this equation where t is a specific value to be solved. Okay, and then the condition is that the length of OQ, that means the magnitude of OQ, is supposed to be 5. So from here, I actually need to find the magnitude. So you take the square roots of the sum of squares, you actually generate the power 2 equation for you to solve. And then from there, you get your two values for your t. What to do next is back substitute your t value back into your equation here. Okay, back into your equation 1, and that will give you the two possible values for your q. Okay, that will be the two position vectors that you are looking for. That's the first part of the question. For the second part, they tell you that point R and point S, both points are on the line L. Condition is that when t is equal to lambda, you actually get the point R. When t is equal to 2 lambda, you get the point S. So you need to tell me, or to show that there's no value of lambda for which OR and OS are perpendicular. So in this question, you see the magic word perpendicular. So surely there must be some dot product involved to be equal to 0. So first thing, find what is OR. So since R and S are on the line L, OR will be this equation where t is equal to lambda. OS will be this equation where t is equal to 2 lambda. Next, follow the instruction. They say that OR or OS are not supposed to be perpendicular because there's no value of lambda for which they can be perpendicular. So I try to do a dot product. Okay, so dot product of OS, OR and OS. And if you actually go through the process, you actually generate an equation here that involves lambda. So your job is to actually solve this thing. So if there's a value for lambda that can make this thing equal to 0, then OR and OS will be perpendicular. But your job is to show that there is no possible value for lambda that can make them perpendicular. So you need to analyze this result that you have. Can OR.OS possibly be equal to 0? So if you actually go through a completing of square, you realize that lambda plus 1 square is always greater than 0, and hence this whole expression here confirm must be greater than 0. There is no way that it can actually become 0, and from there you can conclude that there is no value of lambda for which you can make OR and OS perpendicular.